to diagonalize any matrix. Okay, basically that form is A equals to P P P inverse. That means we can transform B matrix to A matrix with the help of this transformation equation, that is called the similarity transformation, where B is basically the matrix is formed with the help of eigenvalues of A. So here B is called the diagonal matrix. It is only the diagonal matrix. And P is basically the transformation matrix which helps to transform B matrix to A matrix. Okay, and P is formed with the help of eigenvectors of A. Okay, so here this is the matrix, so we can use any function here, like for M and M for M matrix we can write this like this way, that is the M equals to P D P inverse, where D is the diagonal matrix of M. Now this is for the matrix directly, so we can write it as a function also, that is f of M is equals to P f of D and P inverse. Okay, like this way we can write. Okay, now let's find the eigenvalues for the matrix M. With the help of we can build that diagonal matrix. So what will be the eigenvalues of this matrix? Let's find. So mod of M minus lambda I equals to 0. So if we solve this, then get 2 minus lambda whole squared, then minus 1 equals to 0. Then from here we can say the lambdas are a squared minus b squared, a plus b, a minus b. So one lambda will be 1 and another one will be 2 plus 1, another will be 3. Okay, so lambdas are 1 and 3s. So with the help of we can build that D matrix here. So D is nothing but let's take lambda 1 as 3, so 3 0 0 and 1. This is the D matrix, that is the diagonal matrix for M. But here f of M is cos of pi M by 6. Now if you want to find f of D, so f of D also an operator, so obviously the eigenvalues should satisfy this function f of D. So corresponding this, if we take the lambda 1 as 3 and lambda 2 as 1, then corresponding f of D we can find f of lambda 1, so that is f of 3, and f of lambda 2, that is f of what, f of 1. Okay, for f of 3 it gives cos of 3 pi by 6, that is cos pi by 2, so it gives 0. And for 1, cos of pi by 6, that is 3 by 2. Okay, so with the help of this we can build that f of D diagonal matrix. So f of D will be f of lambda 1 0 0 f of lambda 2. Okay, fine. So it will be 0 0 0 then root 3 by 2. Okay, now let's find the P. So to find P we have to initially find the eigenvectors of M corresponding these two eigenvalues. So let's find. So corresponding lambda 1 equals to 3, eigenvectors will be, so 2 minus 3 diagonal elements, subtract lambda from the diagonal elements 2 and 2 here. So 2 minus 3 gives 1, negative 1 1 1 negative 1, then x1 x2. Let's take this column matrix is the diagonal eigenvector for this eigenvalues. It gives 0, that is 0 0. Okay, so from here we can say that x1 equals to x2, so therefore the eigenvector corresponding to this eigenvalue will be 1 and 1. Okay, similarly for the lambda 2 equals to 1, it gives 1 1 1 1, x1 x2 0 0. So x1 equals to nothing but minus of x2. Okay, so we can say that x is here nothing but 1 minus 1. Okay, so we can write the P matrix obviously. P matrix will be 1 1 1 minus 1. So this is the P matrix. Now this but so P matrix we get, P matrix is nice. Now to solve Now we need P inverse also. Okay, so P inverse also. So P is 1 1 1 minus 1. Now write P inverse. So for finding the inverse of a 2 cross 2 matrix is very easy. That is, replace the diagonal elements, shuffle the diagonal elements position. So here minus 1 1, and change the sign of the of diagonal elements. So 1 1 here, so minus 1, and into determinant 1 divided by determinant of it. So what will be the determinant? Minus 1 minus 1, so it will be minus 2. So multiple minus 1, or we can say common out minus sign from the matrix, so it gives 1 by 2 1 1 1 minus 1. Okay, now time to find the f of m. So f of m is nothing but cos of pi m by 6. So f of m will be p matrix. So p matrix is 1 1 1 minus 1. Then the f of d value, so f of d is nothing but 0 0 0 root under 3 by 2. Then p inverse 1 by 2 1 1 1 minus 1. So we can take 1 by 2 in front of it. Okay, so 1 1 1 minus 1, so multiple it, so 0 0 root 3 by 2, then minus root 3 by 2. Okay, again multiple half f of m here, cos of pi m by 6. Okay, so half root 3 by 2 minus root 3 by 2 minus root 3 by 2 root 3 by 2. Okay, so ultimately the answer will be cos of pi m by 6 nothing but root 3 by 4 matrix 1 minus 1 minus 1 1. So option B, I think, yeah, option B is the correct answer. So thanks for watching.